I'm now going to continue my review of Danica McKellar's Math Doesn't Suck book with this. I honestly agree with Danica McKellar that math word problems are often difficult to translate. No question about that. Have you ever tried to translate an ACT math problem? Or have you ever struggled with the proofs in Euclid's Elements? We know we have. Okay. So how does a person solve this reading problem? Well, first of all, I would suggest learning a much larger vocabulary, because if you don't, you won't even be able to read the word problem, much less try to figure it out. Okay? Danica McKellar makes a brief reference to reading hidden meanings out of text messages. This part's going to become very interesting. It's a cute idea to think about, but I believe that this way of thinking will not be very useful in solving math word problems. It's a great way to introduce a chapter, but yeah, this is not going to help with word problems, I assure you. But let's examine what Danica McKellar states in her book. The first thing that she has you envision is some kind of a guy texting a female. Okay? We have some dude texting a young lady. Okay? And in the text, this guy says, hey, you know, I'm kind of interested in what you're doing right at the moment. Maybe it's doing origami, or maybe she's planting flowers. Whatever, it doesn't matter. He has actually now said in his text that he's interested in what she's doing. Okay? So, at this point, this particular female may end up presuming that this guy really is more interested in her than he is actually interested in what she is doing. Which I can get. I truly comprehend that. That could happen. Okay, I get it, especially if she finds this guy physically attractive. Okay, fine, great, fantastic. But here's the problem with the book. Danica McKellar actually admits that it may be possible that the guy is just interested in her activity rather than in her. She makes that concession in the book. But she never addresses what to do about that. She never says, hey, you know, when you have a situation like that where you think this guy might be interested in you, but you're not entirely sure, to take the following steps to try to figure out whether he's really interested in you or in the activity you're doing. I mean, here you could be just riding around a motorcycle. Maybe he's interested in motorcycles and he sees yours, he sees that it's a rather unique motorcycle, and there you go. It may not be that he's particularly interested in you, maybe he's just interested in the motorcycle. What happens then? How do you know for sure if he's interested in you or what you're doing? She never addresses this. And I think it's not in the book. You can go check it out for yourself. She makes no mention of this in her book at all. And I'm sitting here going, maybe you should strike up a big-time conversation with the guy and find out what his true interests are. Because if you don't, you could be very badly disappointed. I mean, this could crush some girl's spirit. Okay? Especially when she's dealing with very young ladies here. You get the picture? Okay. So, I mean, think about that for a second. Think about how awkward the situation would be if she honestly thought that this guy was interested in her, and it turns out, because of the conversation, that he's just interested in whatever she's doing and not interested in her at all. It could make for a pretty awkward conversation. So, yeah, that topic, if you're going to cover something like this, you need to cover both ends of the spectrum. And I don't think that Danica McKellar did a very good job of doing that in her book. So, alright, so like I said, I think all young ladies should develop good communication skills so that they can find out what this guy is thinking. Is he interested in you, or is he interested in what you're doing? Okay? That way you don't build up your hopes really, really too high, because I'll tell you what, you build your hopes that high and you find out this guy is interested in what you're doing and not really interested in you, your hopes can be dashed pretty quick. So, just be careful. Possessing a great vocabulary is one large key in solving math word problems. This is why I teach the language of Italian on my YouTube channel. As you may or may not have guessed, 60% of your language comes from the language of Latin. And the language of Latin was created and used in the nation of Italy approximately 2,000 years ago. It's easier to learn Latin if you have learned the Italian language first, because you got the basic grammar structure, so on and so forth. And if you learn Latin, you will be able to store a dictionary in your head. This means you will struggle less with math word problems. That's just a given. Danica McKellar continues her presentation by discussing mathematical symbols. I shall now take a moment to discuss the origins of some of these math symbols, which you will not find in her book. So let's start with what people would call the plus symbol. Okay? Now this plus symbol originated as a form of the Latin word et. Okay, now if you are familiar with Latin at all, you know that the word et is actually the conjunction and. Okay? So, what about the equal symbol? Well, Mr. Robert Record, yeah, that's his name, Mr. Robert Record, created the equal symbol because he was writing a book entitled Whetstone of White. I would say that's Whetstone of White. If you need the name of the book, let me know and I'll put it up here in the description. Okay. The origin of the minus symbol is somewhat of a mystery. We are not entirely sure where this thing came from. Some people have suggested that its origins can be traced back to hieroglyphics. The multiplication symbol has a very interesting history on its own. It was designed by a guy by the name of William Oughtred to represent the religious symbol of the crucifix. Okay? Now, if you want more history on that, let me know and I'll get that to you. The division symbol most people are familiar with, okay? The division symbol that people like me would be more familiar with is supposed to be called the obolus. And if I got that wrong, please just let me know and I'll correct it. I'm not very good at these kind of pronunciations. Okay? Just because I can't pronounce things correctly doesn't necessarily mean I don't know what I'm talking about. The first use of this particular symbol can be found in a book entitled Technische Algebra, which was written by a name by Johann Heinrich. Yes, that's a German name. At least I was able to pronounce the name. Of course, I could give you more math symbol origins, but I think, let me try that again. Of course, I could give you more math symbol origins, but think about how long this video presentation would become if I did. Honestly, I think anyone who reads Danica McKellar's Math Doesn't Suck book would be very interested in this mathematical history. But at this point, I digress. She wrote the book, I didn't. Okay? Danica McKellar is also correct in stating that many countries around the world use the same math symbols that we use here in the United States, despite the fact that very few countries in this world fluently speak English as their primary verbal language. That's true. However, I have to disagree with Danica. Boy, I'm really just screwing this up, aren't I? Well, let's trudge on, shall we? However, I have to disagree with Danica McKellar when she states that in certain circumstances, the word of in a math problem represents multiplication. Now, allow me to explain this, okay? What if I asked you the following math problem, okay? What if I said, what is What is 1/3 of 9? What if I gave you that? Now, in her book, she replaces the 1/3 with the numerical equivalent, which would be 1/3. She also replaces the 9 with a physical 9. But I'm not going to do that here, because this is exactly what you should be doing. You should be able to read this in English language. That's what you should be doing. And for her to do that, I'm like, really? Uh-huh. Yeah. I'm sorry, I disagree with that totally and completely. If you were in my math class, this is how you get it. And you would learn this. Okay? So, if you're talking word problems, that's how a word problem is supposed to be presented, as far as I'm concerned. Alright. Now, Danica McKellar is correct in stating that you could use an alternative method to okay. Skip that. Hang on. Let's go back a minute. What is this math problem actually asking you to do? Well, it's asking you to divide the number 9 into 3 equal parts. That's exactly what they're doing. They're saying, can you divide this number 9 into 3 equal parts? That's exactly what they're doing. So that is more of a division problem than an actual multiplication problem. So you could actually place the number 9 in the numerator of a fraction. You could do that. And then you could place the number 3 as the denominator of the fraction. Okay? You reduce the fraction, and you have 3/1, or the answer of 3. Okay? So, where do I actually agree with Danica McKellar? Despite the fact that this actually is more like a division problem than a multiplication problem, you can actually use multiplication to solve this. Okay? We could have multiplied the number 9 by 1/3. We could have done that. Okay? And we would have still gotten our answer, you know. We still could have got the answer of 3. But what I'm trying to say here is that I want you to visualize what you're doing. You're actually dividing that 9 into 3 equal parts. That's what you're doing. And if you're not visualizing it this way, it might confuse you in the end, because you're sitting there going, well, that's a multiplication problem, and the teacher's saying, no, that's really a division problem. Really. Okay? Now, I will be fair to Danica McKellar and say that she is right in stating that if you're using the word of, which is right here, and the word of is surrounded by numbers, this is a number 1/3, this is a number 9, then you could treat it like a multiplication problem or a division problem. Okay? You could either do it my way as a division problem or her way as a multiplication problem. Doesn't matter either way. However, if there is an extra word attached to that of, you may have a completely different math problem. Now let us suppose that I was going to sell you a fancy shirt. And I tell you that the original price of the shirt is $100. Okay? Now when I tell you that the original price of the shirt is $100, the first thing you're going to see in your head is $100. Then I'm telling you that I'm going to remove 60% from that price. Ooh. So what I'm asking you to do is to figure out what that 60% of that price would be, and then to figure out what you're actually going to pay for that shirt. Because obviously you're not going to pay $100 anymore. If you're removing 60% of that price, you're only going to pay 40% of the item. Okay? So you're probably going to pay about $40. Okay? So when you see the combination of the words off and of, if you see the combination of the words off and of, that's more likely going to be a subtraction problem than a multiplication or division problem. Okay? So you gotta watch that. It's a little tricky. And Danica McKellar, to be fair, mentioned this in her book as well. Okay? Alright. So, the next thing Danica McKellar does is she reminds everyone that you can convert numbers that are presented as percents into fractions before you use them in a math problem. She's absolutely right. So, if I asked you to find 60% of the number 20, so I asked you to find 60% of $20 bill, of a $20 bill, well, you could actually convert this 60% into 3/5. And then you'd multiply that by the $20 bill. And then you would get the answer. Or, like I said originally, I mean, that's Danica McKellar's way, but you could do it my way. You could actually divide 20 by 0.6 and just reduce the fraction. Okay? At this point, Danica McKellar offers some additional translations that she thinks will help her students, because she tries to translate some other words. I agree with many of these translations. They include the words sum, more or less than, and difference. I will even go as far as to say that the word is and are should indicate to you the word equals when it comes to math problems. That's true. Now, it is 100% true to say that obviously the word quotient, as I have covered in a previous video, always indicates some kind of a division problem. But what about the words per and the letter A? She doesn't elaborate on this point in this chapter, so I guess we will have to wait and see what she means by the words per and A. We'll find out in a future video. Now, I have to admit again that Danica McKellar is correct in saying that various parts inside a computer communicate in the language of mathematics. I mean, this is where you get your bits, your bytes, the whole 9 yards. I just did a video about random access memory, which should give you some clue as to how computers actually communicate. They communicate in bits and they communicate in bytes. That's all true. Okay? Of course, she doesn't elaborate on any of this. The reason for this has to do with binary and electrons that are stored inside capacitors on computer integrated circuit boards. Okay, that is the language of computers. That literally is. I'm sorry that that was never mentioned in her book, but it isn't. Go ahead, try to find it. It's not there. It's for the same reason that computers are able to communicate with each other, because the computers actually communicate in bits and bytes, or literally electricity stored in capacitors. Get it? Okay? It would have been nice if she had stated that in her book, but she didn't. It would have been much more fascinating. But I would also have to say that mathematics is only a secret code until you learn how it actually works. And that's why people like me are around to explain it to you. And it's not terribly difficult to learn this code. You just have to have a proper guide. And I like being your guide, since you're here. Thanks to Harry Lorraine, you can retain much of this mathematical code even if you don't use it regularly. She's saying, well, if you don't use it all the time, you'll forget. Well, maybe, maybe not. If you store it the Harry Lorraine way, you probably won't. You might forget some of it, but most of it will come back real quick. So once again, I encourage everyone to learn Harry Lorraine's memory techniques, and that's pretty much the end of this video. I will continue my review of Danica McKellar's Math Doesn't Suck book in a future video. So I'd like for you, before I go, I wanted to tell you that I've actually written 5 Kindle books of my own. If you want to read them, let me know. I will you just leave me a comment below and I'll leave you a link so you can buy my Kindle books. Okay? I will tell you more in a future video, so I'd like for you to stay tuned.